Welcome everyone. In this video, we are going to be looking at centripetal acceleration and centripetal forces definition and calculation involving them. Okay. Here we see what centripetal acceleration is. Centripetal acceleration, also called radial, so another word for centripetal is radial, is the acceleration that causes an object to move along a circular path or turn. So that acceleration that causes an object to move in a circular path. Okay. So whereas ordinary tangential acceleration, which we saw in the previous video, points along or opposite to an object's direction of motion. That means it's tangent. Let's put it this way. If I have, let's say, my circle, now the radial acceleration goes inward, pulls inward, causes it to move. But the centripetal, that's the radial acceleration, but the tangential acceleration acts exactly at the tangent this way. Okay, so um, making a right angle with the object's velocity vector. Exactly. In fact, because of its direction, centripetal acceleration is also referred to as radial acceleration. Okay, and it has a constant value. Centripetal acceleration is v squared over r, and which is equal to omega squared r. The same thing. Remember, from our previous video, we learned that v equal to omega r. Okay, so if we substitute omega r for v squared, we are going to get omega r all squared divided by r. Okay, that will give us omega squared r squared divided by r. So r cancels one of these, so it gives us omega squared r. Okay, so the same with centripetal force. So centripetal force is a force that acts on a body moving in a circular path and is directed towards the center, okay, around which the body is moving. So centripetal force is always directed towards the center. Don't forget that. Centripetal force is mass times centripetal acceleration, which is mv squared over r, or you say m omega squared r. They are all the same. So we see a question here. It says a 2 kilogram body is tied to the end of a cord and whirled in a horizontal circle of radius 1.5 meters at 3 revolutions per second. Okay, determine the linear speed, and that's first, then the centripetal acceleration, then the force. Okay, first of all, the linear speed v is equal to omega r. But we are not given omega, we are given frequency. We can still write that as 2 pi f then r. Okay, so that will give us 2 pi times the frequency, there is 3, then multiply by r, which is the radius, is 1.5. Okay, so that's going to give us 9 pi meter per seconds. Okay, 9 pi meter per seconds. Okay, so with that we can now find the next question. That's for A, the centripetal acceleration. The centripetal acceleration here can now be A equal to v squared over r. So that means 9 pi all squared over r. Our radius here is 1.5. Okay, and that is going to give us 81 pi squared over 1.5. Okay, and that is going to give us 54 pi squared. So the answer here, 54 pi squared meter per second squared. Okay, that's the acceleration, 54 pi squared meter per second squared. Now for the centripetal force, we can say that centripetal force F is equal to mass times centripetal acceleration. The mass is 2, the acceleration is 54 pi squared. Okay, and that is going to give us 108 pi squared newtons. You can as well substitute the value of pi, which is 3.14, and get a final answer there. Okay, that brings this class to a close.